is okay. All right. So were you by any chance able to take a look at the one I sent you on WhatsApp?
Yes.
Okay. All right. Okay. So we're starting with number 30. 30, 30, 30. What does it say? So remember, if there's anyone that you've been able to solve by yourself, just let me know so that we skip it. Okay. So number 30, the value on Michelle's car decreased by 15%. The car now has a value of 13,600 pounds. Work out the value of Michelle's car before the decrease. Okay, so I think I'll use that method that you're comfortable with. The first thing I'll do is to subtract 15 from 100%, and I think that should be 85. Okay, so 85% is 0.85. Okay, 0.85 of the original price. Okay, so remember, we're supposed to work out the original price before the decrease. So let's use a letter to represent that. So that's the original price, P. Okay, so 0.85 times P, we're told should be equal to what the question gave us, which is 13,600. Okay. All right. So did you get that? Did you get it up to that point?
Yes.
Okay, good. All right. So we're looking for P. This one is pretty easy. We'll just divide both sides by what? 0.85. So since this question allows us to use a calculator, I think you can go ahead and use your calculator and do this. 13,600 divided by 0.85. What does that give you?
16,000.
Did you say, what did you say?
16,000.
16,000. Okay. Okay. So the answer is 16,000. Excuse me. Sorry. 16,000. Okay. All right. And clearly that looks like a correct value because it's supposed to be higher than what it is before it decreased. So that's fine. Okay. So moving on. Okay, number 29. I think this is the first time I'm seeing this kind of question. Change 30 meters per second to kilometers per hour. Change 30 meters per second to kilometers per hour. All right, so remember that what I told you, I can't remember whether it was here or in physics or chemistry, but I know I said something about units. When they say per, anytime you see that word per, just imagine that it's a division sign. And then whatever comes after the per, we're imagining that it's in the denominator, right? And that it has a value of 1. So that's what we see, that's what we have. So when they now say change something like this to a different unit, so that means that we have to find something that's equivalent to it. Now, if I were to convert 30 meters to kilometers, I want you to see what I'm going to do here. We know that 1,000 meters makes 1 kilometer, right?
Yes.
So that means if I were to convert from meters, sorry, if I were to convert from meters to kilometers, what direction would I be going in? I'll be going in this direction, isn't it?
Yes.
So that would mean I'll be dividing by 1,000. So look at what's going to happen here. That would be 30 divided by 1,000. Okay, this on its own is going to convert 30 meters to what? Kilometers. But that's not all. There's still the main division sign that was there. That's the original division sign, which is this guy that I'm emphasizing on the left-hand side. Now, 1 second, how do you convert seconds to hours? Because we know that 60 seconds make 1 minute, but 60 minutes makes an hour. So that means that 60 times 60 seconds, right, would make 1 hour. So in which direction am I going again? I'm going from seconds to hour. So I'm going to be dividing by 60 times 60. So what value do I have under there? I have 1. So that's 1. Okay. 1 divided by 3,000. I'll just multiply it so that it will make things easy for me. 3,600. Now, okay, so let's see. What do we have here? So now what I have is, so that we can quickly get this out of the way. 30 divided by 1,000. Okay, this what it is equivalent to, divided by 1 over 3,600. And guess what? What's going to happen? When you change that division sign to multiplication, it's going to leave us with this. 30 over 1,000 times 3,600 over 1. Okay, so I'm sure you know what's going to happen. Things are going to go. I have 2 zeros going here, 2 zeros going here, 1 0 going here, 1 0 going here, leaving me with 3 times 36. So 3 times 6 is 18, and 3 times 3 is 9, plus 1, 10. So the answer would be 108 kilometers per hour. Okay?
Yes.
All right. So, all right, so we can go on, right?
Yes, yes.
Okay, cool. I just have a funny feeling that I should change the color of this guy. Let me change it to green or red. Okay. Okay. All right. So this looks like okay, say proof. Show that A equals 2x squared plus 20x. Okay, so let's just look at the question on the whole. It says the diagram shows a rectangle STUV and TQU and SRV are straight lines. Okay, we can see that. It now says all measurements are in centimeter. And what does it say next? The area of trapezium, QUVR is ACM squared. Okay, so let's even establish where QUVR is. This is Q, this is U, this is V, and this is R. Okay. The area of trapezium QUVR is ACM squared. The question now goes that you should show that A is equal to 2x squared plus 20x. Okay, in other words, they're trying to say that we should show that the area of that trapezium can be given by that expression. So the first thing we would need to do is this. remind ourselves what's the formula for the area of a trapezium. So, okay. Okay. So A, for a trapezium, let me just write the general formula before we come back to this guy. I think it is half into bracket, small letter A. Don't worry, I'll explain what all these guys are. But I have a feeling you have an idea of what they are, but I'll still explain them. Half A plus B H. Okay. All right. Of course, we know that a trapezium has two sides, two parallel sides. So that's what the A and B stand for, the parallel sides. And then the height is of course, we know the vertical height. And of course, the half comes to play. So let's keep this in mind, that this is the formula for the area of a trapezium. Then we'll come back to apply it. Now, if I were to look at this diagram very well, the two parallel sides for the shaded part, that's the trapezium we're interested in, are 5. That this 5 is a parallel side, and this one is parallel too. The question now is, from here, T to Q is 2x. The question now is, what is the value from Q to U? That's the question. So let's find out how we would figure that out. Remember that the whole structure is what? A rectangle. So we are free to also invoke the principles and the properties of a rectangle. Okay, and we know that those properties are very simple. Opposite sides are equal and parallel. So that's a fact we can depend on. Okay, so if they're equal, then that means that this side, which is SV, which is equal to 3x plus 5. Take note, I said 3x plus 5, not 3x plus 5x. I'm just trying to stay in line with the question. 3x plus 5 is going to be equal to what you have on top here, which is what? 2x plus what we don't know. Okay, so I'm just really hoping that it's not an error, but yeah, that's fine. All right, so let's see. Yeah, okay, so if altogether here is 3x plus 5, then that means that, let me see if I can establish some things here. 2x plus, let's call this place B, okay? Let's call this place B. We already know that here is our A for our trapezium, okay? So B is what we don't know. B is what we're looking for. So 2x plus B is equal to, remember, the opposite side of this rectangle is what? 3x plus 5. So 3x plus 5. Okay, so our question now is, what is B? So let's quickly find B. B will be equal to 3x plus 5 minus 2x. Do you agree with that?
Yes.
Okay, which will further become, now because of the like terms, 3x can take care of 2x. So everything will now become 3x minus 2x, which is x. So we're now left with what? X plus 5. Okay, so are you with me up to that point?
Yes.
Okay, good. So we'll just simply, anywhere we see B in our formula, we're simply going to put what? X plus 5. All right. So here we go. Now, remember our A is already 5 and our B is x plus 5. Now, the height is from here to here. This is the height of our trapezium because the height is the vertical line that links the two parallel sides. So what's that height? Again, we will invoke the property of the rectangle, which says that opposite sides are equal and parallel. So the opposite side is this guy, which is what? 4x. So the height is also equal to 4x. So let's go and throw in things in our formula. Let's see how it goes. So A, which is the area, is equal to, we'll start with half into bracket. Small letter A is 5. We've already established that. Plus B is what? X plus 5. X plus 5. I'm just substituting things now and watching, hoping that everything will play out. And then my H is what? 4x. So let's see how this goes now. So let's deal with the guys inside the bracket before we come to the guys outside. So what's happening inside that bracket? I'm going to have what? What do you think will be happening? What do you think will be inside the bracket?
So what would be A?
Yes, just this at this point. What's inside the bracket?
5.
Okay, so yes, but look at this 5 and this 5. They are free to interact, isn't it?
Oh, okay.
Yeah. So that would be x plus 10, right?
Yes, yes.
So that's x plus 10. Now, remember that outside the bracket, we still have half and 4x. So, and guess what? The relationship between 4x and the bracket is multiplication. And the relationship between half and that bracket is also multiplication, which leaves me to conclude that this 2 is free to divide into the 4. Okay? So what am I left with at the end of the day? 2x will be will be outside into brackets what? X plus 10. Okay. Now I want you to notice something. I know that you probably have an idea that this, what I'm about to say now, is the fact. But somebody could have equally said that, could have equally thought that 2 could have gone into the 10. But that would have been a violation of mathematical laws because of this plus sign. Okay, so that's why, that was the reason why I didn't say 2 into 10, 5. I went straight for the guy that was interacting with the bracket by multiplication. And just like this guy too was interacting by multiplication, they have. Okay, so that is what I have. So are you good with the what do you call it? The calculation up to this point?
Yes.
Okay, so I'm sure you can see the answer coming out now. So A will finally be equal to, so you can now expand. So 2x times x will be what? 2x squared. And then 2x times plus 10 will be plus 20x. Okay. All right, so we've just gotten to the final answer right here. Okay, so is there any part you want me to explain again, or you're good?
Then I'll find.
Okay. All right, so moving on. Does this look like something you can handle? Jessica runs for 15 minutes at an average speed of 6 miles per hour. She then runs 40 minutes at an average speed of 9 miles per hour. If it takes Amy 45 minutes to run the same total distance that Jessica runs. And then it says, work out Amy's average speed. Give your answer in miles per hour. Okay. Do you want us to take on this?
Yes, please.
Okay. All right. So average speed's formula is just same as speed, which is distance over time. I mean, even the unit gives itself away. Okay, so miles per hour, right? MPH. Okay. Now, let's see. Since uh, um, um, we're actually dealing with only two people in this question, Jessica and Amy. So let's see. The total distance. So our first job is to find out what's the total distance that Jessica runs. So let's say that that is D, right? So total D will be equal to D1. I'm sure you have an idea what I mean by D1 plus D2. Okay. So D1 is the distance that Jessica ran for the first 15 minutes. Okay. And okay, so let me just remind us that speed is equal to distance over time. Okay. So therefore, distance will be equal to what? Speed times time, isn't it?
Yes.
Okay. So once we have that established, we can continue. So D1 is going to be equal to speed times time. And remember, the speed is in miles per hour. So we have to convert 15 minutes to hours. So this is what we're going to do. 6 times 15 over 60. All right. Put this in bracket because I think we'll come back to handle it. Plus D2 is 9 miles per hour. So that's going to be 9, that's the speed, times, don't forget to convert that other guy to hours too. 40 minutes to hours. That would be 40 divided by 60. Because we all know that 60 minutes makes 1 hour. Okay, so without much ado, 15 in here is 1, 15 in 60, 15 goes in 64 times. Okay. Of course, we already know that this 0 will cancel this 0. Can 2 do something here? 2 can go in here 2 times. 2 can go in 6 3 times. 3 can go in itself 1 time. And 3 can go in 9 3 times. So that will leave me with, okay, I didn't even finish with this one. 2 in 4, 2 times. 2 in 6, 3 times. So that will leave me with 3 over 2 plus 3 times 2 is 6. That will be 6 over 1. Okay, so just to make things simple, right? I don't want to start doing LCM and all that. 3 over 2, we already know is 1.5. And if we're adding it to a whole number, which is 6, this is what is going to happen. The whole number will add itself to the whole number here. So 6 plus 1 is what? 7.5. We'll make everything to be 7.5. So now we have been able to get the total distance, which is 7.5 miles. Okay, so let's not forget that it's in miles, not in kilometers this time. Okay, so on to the next. They said if army takes 45 minutes, take note of that, 45 minutes to do what? Run the same total distance that Jessica runs. That's 7.5 miles. The question is this: work out army's average speed in miles per hour. So, of course, this is for army. So let's take note of that. What we're doing now is for army, not Jessica anymore. So army's average speed is going to be equal to, sorry, let me specify that speed we're looking for. And remember, average is just, I don't know whether to call it just a title, but it doesn't change what speed is. It's still distance over time. So that's going to be, because of calculations, maybe we should just, okay. Yeah, I think I can still play with it. 7.5, that's distance over time. And the time is 45 minutes. Now, remember that 45 minutes, for it to be an hour, we have to convert it to hours. So that's, let's put it in its own shell there, 45 over 60. So this is what is going to happen now. 7.5 is the same thing as 15 over 2. And since we're dividing it by 45 over 60, it's as good as multiplying it by 60 over 45. So things can now play out very nicely. 15 will go in itself one time. 15 will go in 45 3 times. 2 will go in itself one time. 2 will go in 60 30 times. 3 will go in itself one time, and 3 will go in 30 10 times. That leaves me with the last man standing, which is 10. And the answer should be 10 miles per hour. Okay. So, did you get that? Hello, Noah, are you there?
Yes.
Okay, did you get what I just explained? Did you get the calculation up to that point?
Yes.
Okay, all right. Okay, I almost thought your network went off. Can you handle this guy? Frequency. Sorry, I hope that's all in that question. Can you handle this?
Yes.
Okay. How about this one? Should we solve it?
Yes, please.
Okay. All right. So it says Joe is going to buy 15 rolls of wallpaper. Here are some information about the cost of rolls of wallpaper from each of 2 shops. Okay. So these are, I guess excuse me, these are the names of the shops. All right. 3 rolls for 36 pounds. Pack of 5 rolls, normal price 70 pounds, and 12% off the normal price. Okay. Okay, pack of 5 rolls at the normal price would enjoy a discount of 12% off the normal price. The question is, Joe wants to buy 15 rolls of wallpaper as cheaply as possible. The question is, Should Joe buy the wallpaper from Chic Decor or from Style Papers? And it says you must show how you get your answer. So clearly, this is a question that needs us to compare, needs us to do some form of comparison. So we're going to go with, let's start with Chic Decor first, or Chic Decor. Okay, so I'll just use C to represent it for Chic. Okay, so it says 3 rules for 36 pounds, no discount at all. So let's see how that plays out. And remember, Joe needs 15. So how many 3 rules are there in 15? That would be 5, isn't it?
Yes.
So 5 3 rules will give us 15. So if that's the case, and I think this applies for all of them, 5 3 rules, but anyway, I don't know, the other guy may have something different. 5 3 rules will give us 15. That means the price of what he will spend to buy 15 rolls of wallpaper would be 5 times 36. Okay. I shouldn't do this, but I think I can just do it because of the nature of this. So 5 times 36, that's 5 times 6 is 30. 5 times 3 is 15 plus 3, 18. Okay. So that's 180 what? Pounds. That is from Chic Decor. So let's see what he has from Style Papers. So I'll just call it Style. Okay. So for Style Papers, it says a pack of 5 rolls would enjoy 12% off the normal price. That's how I'm interpreting that bit of the question. But the normal price, if it's not up to 5 rolls, is 70 pounds. Okay. So let's see 12% of the normal price. So in this case, it's 3 times 5 rolls. That's the flip side for Style. 5 rolls. Okay. 3 times 5 rolls. Okay. So we're going to get 12% off the normal price. Okay. So let's get the normal price first, and then we'll now get 12% off that. Or should we just do the 12% first? I think we should do it on the total. Okay, so that's 3 times 70. That's 210. Okay. So let me see. 12% off. 12% off. Okay. So 12% off is going to be if we do that, the same thing that we did for decrease back there, right? That's going to be 100 minus 12, isn't it?
Yes.
So 100 minus 12 will give us what? That's 88. Okay, I think that's 88. So 88%. So that's going to be 88% or 0.88. So the price that he will pay will be 0.88 times 210. Can you help me crunch this on your calculator? Let's see what it will give us. 0.88 times 210.
184.8.
100 and what?
184.8.
184.8.
Yes.
Okay. So clearly we can see that style is slightly higher than cheek. So yeah. So you know the funny thing. I have a feeling that some people will just on surface value conclude that style papers, because style papers give a discount, then theirs is going to be obviously cheaper than cheek that don't give a discount. But if we are to go with what the question says, it says she wants to buy rolls of wallpaper as cheaply as possible. So every pound counts in this case. So that's the catch, as cheaply as possible. So yeah, so I think we will advise him to go with cheek decor, which is this guy. Okay, so I think we can move on. All right, do you have any question for that other guy?
No, no.
No, okay. All right, so let's look at this one. Is it something you can do? It looks like a ratio and probability in a mix. Okay, I think this is just ratio. It's just ratio, it's not probability. Okay, is this something you can do?
Yes.
Okay, all right. Okay, so moving on. This is substitution. I think you can handle it. The first one. How about 23B? Can you handle 23B?
Pardon?
Can you take on 23B, the second one, make P the subject of the formula?
D minus 4 divided by 3 equals P, I believe.
Okay. Okay, but you'd have to show your workings, right?
Yes.
Okay, all right, good. Okay, so moving on. It says work out, I guess you can, that's easy. Here is a right angle triangle. What's the question? Work out the value of x. That's Pythagoras theorem. I'm sure that should be something you can handle, right?
Yes.
Okay.
Wait, sorry, can you? Oh, Pythagoras. Okay.
Yes. Okay, this one. You want us to do this one?
It's just.
Okay. You want me to remind you of the theorem, right?
Yes, please.
Okay. Okay, so Pythagoras theorem says that if you have a right angle triangle where you have three sides, the hypotenuse, which is C, and the other side is A, and the other side is B, then C squared, that's the hypotenuse squared, will be equal to A squared plus B squared. So in this case, I think that would mean 8.5, right? 8.5 squared is equal to 4 squared plus x squared. In this case, that's our b, x squared. And we're supposed to find x. So to make x such a formula, we'll take this 4 squared to the left-hand side. And that's going to be 8.5 squared minus 4 squared, which we know is 16, which will be equal to x squared. That's all that will be left on the right-hand side. Okay, so can you help us work out 8.5 squared? What would that give us? I remember I told you something about numbers that end with 5, right? Do you remember?
They always.
Do you remember?
No.
Oh, numbers that end with 5 when you are squaring them. Okay, let me just remind you. Let me use this opportunity to remind you. You can, if you've already done the calculation, just hold it. Keep the value in front of you. I want to show you how you can do it in case you wanted to like quickly just get it out. So numbers that end with 5 and you are squaring them, we know that 25 is part of the answer, right? So the next thing that we need to do is to look at the number that's in front of the 5, and that's 8 in this case. And then add 1 to 8, that's 9. So that's the next number after 8, that's 9. Then we multiply 8 by 9. 8 times 9 is 72. So the final answer would be 7225. But because you have 0.5 at the top and 0.5 in the other number, it's going to be 72.25. Okay. Was that what you got for 8.5 squared?
Yes.
Okay. Okay, I just felt like I should remind you because that's a fast way for questions that won't allow you to use calculator. Okay, but here we are. So can you help me with this? 72.25 minus 16. What do you have as your answer?
56.25.
Yeah, 56, remember, 0.25. Okay, numbers after the decimal points, you call them by their digit names. Okay, not 25 now, but 25. So you're looking for x. So x will be equal to the square root of 56.25, which is, can you help me with that on your calculator? I think I have a feeling it's 7.5 because of this 25 I'm seeing ending it. What did you get?
7.5.
7.5, yes. I was able to guess it because of the 56, because 7 times 8 is 56. And we already have 25 there. So yeah, there you go. 7.25 is your answer, centimeters. All right. So you're good with this, right?
Yes. So you always square root it at the end of the calculation.
What did you say?
At the end of Pythagoras equation, you always square root.
Yes, especially, yes. It will always end with a square root. And that's because all the terms, like you can see the C, the A, and the B are all squared. So if you need the any of the sides, at the end of the day, you have to find the square root of, whatever it is you are going to end with. Okay, so are you good with that?
Yes.
Okay. All right, so let's move on. Okay, so for this guy, we see some parallel lines playing in the mix, and they're asking us some questions. It says in the diagram, PQR is an isosceles triangle. We remember isosceles triangles. Two sides are equal, and the two base angles, the two angles which are on those, touching those two sides are equal. That's the property of isosceles triangle. So what does it say? It says PQR is an isosceles triangle with PQ. Where is PQ? Let's quickly locate PQ. Okay, so can you even see the sign? See that sign there? PQ equals QR. That's our identification mark, that they are equal to each other. Equals PR, sorry. Next, we're now told that APR and CQD are parallel lines. APR and CQD are parallel lines. This is actually what shows that they are parallel. This and this, okay, are parallel lines. And what does it say next? BPQ, where's BPQ? BPQ is a straight line. Okay, quite obvious. Now, it now tells us that angle APB is equal to 56 degrees, which is there. That's our guy there, 56 degrees. What next? It says, work out the size of angle CQR. That's Q, CQR. That means they want us to find this whole angle. Can you see that?
Yes.
Okay. Now we've established what they want us to find. Our job now is to find it. It says, give a reason for each stage of your working. These guys are really detailed. They want to see, they want to know that you know what you are doing. Okay, so let's start. Now remember the properties that we're going to invoke, their principles. For parallel lines. Parallel lines have interesting properties. Remember, I think in the last one, we talked about Z angles. The Z angles are the alternate angles, the one that look like a Z. Okay, so if you can see two parallel lines, sorry, that second line I just drew now doesn't look parallel at all. Okay, so if we have two parallel lines, let me just pretend that these are two parallel lines, try my best. And then you have a straight line crossing them. The Z angles are this one, this, and this. That's why they call them Z angles. And these are alternate angles. Now, we have corresponding angles. Those ones are not Z angles. So if you want to look at the corresponding angle in this case I just talked about, then corresponding angles are the angles which are on the same side of the parallel lines. So the corresponding angle to this angle I just marked is going to be this. This is the corresponding angle because it's on the same side of this parallel line and this parallel line. Of course, compared to the, what do you call it? The line that is traversing both of them. Okay, so remember that alternate angles are equal, corresponding angles are equal. So let's go. Give a reason for each stage of your working. So let's start. Now, my question is, let's start with this angle. What is this angle that I'm marking now? This angle like this, what is it? So let's find what is this angle in terms of either alternate angle or corresponding angle. And if you look at it very well, I don't know whether you can see that this angle here is also 56. Do you agree that this angle here is 56 degrees? Look at it carefully. Corresponding angles. Okay. Now, I need to say something about corresponding angles. If you look at it on the surface, it looks as if they can slide into each other. If you look at it carefully, do you agree with that? It looks as if they can just slide and they just fall into each other. Do you agree?
Yes.
Okay. Okay. Now, I've established part of the angle I'm looking for. So, but now let me name that angle because they said we should give reason for each stage of our working. So CQ, I can't write that angle thing because it's going to take my time. Let's call it CQB, right? Angle CQB is equal to what? 56 degrees. And what's the reason? I'm not going to write corresponding in full, I'm sorry, but you know what I'm trying to say. Corresponding angles, okay? Okay, next, the remaining angle we're to find now is this guy like this that I'm reinforcing. Okay, so question is, how do we find it? Let's see if any other thing here can give us a clue. Good. I can see that I have an isosceles triangle here. So you know what I'm going to do? I'm going to try and find this other angle. Why? Because this other angle is equal to this angle. So if I can find this angle, automatically I found this angle. So question is, what is this angle? Let's see if we can find something that will give us a clue. Something that will give us a clue, a clue, a clue, a clue. Okay. Oh, I've seen the clue I'm looking for. Yeah, not too far. Now, there's something called vertically opposite angles. Okay, vertically opposite angles are also equal. What do I mean by vertically opposite angles? Angles that occur at the crossroads of an X. So, sorry, I always try my best to draw straight lines. I don't know why sometimes it doesn't come out well. So this is a straight line, right? And this is another straight line. That is an X. This angle here is equal to this angle. That's why they're called vertically opposite. But that it doesn't stop there. If you also have horizontally opposite, if you would like to call it horizontally opposite, but the one I know is only vertically opposite. So whether they look like they're horizontal or not, but when they are directly opposite each other at the crossroads of an X formation, they are equal. So what does that tell me? It tells me that this angle is also equal to what? 56. Okay, so in fact, there are two reasons for this one being equal to 56. You can look at it this way. Z angles, that's Z, alternate angles, or the one I just said now, vertically opposite angle. This angle and this angle. Okay, they are vertically opposite. So anyone you want, it will still fly. So we're going to now say that, where was I? If this angle is 56, angle QPR, QPR is what? It's also what? 56. And the reason, I can give you two reasons there. It's okay, so let me be specific. Corresponding angle to A, P, D. Okay, that's the reason for that one. This one is alternate angle maybe I'll just stick with one reason, to C, Q, B. Okay, all right. So the next thing I'm going to find out, because now I know that this angle is 56, right? I can find out these two other ones and I'm good. How do I find them out? Remember that sum of angles in a triangle is equal to 180. Therefore, angle P, Q, R, that's one of those angles, will be equal to 180 minus 56 divided by 2. Okay? So I hope I've not mixed two reasons here. Okay. So maybe I should just combine the reasons. So the number one reason, let me do this, make me faster. Sum of angles in a triangle equals 180. 180. Okay, tab. And yeah, I should just go to the next slide. And triangle PQR is oh, sorry, that's not the spelling of isosceles. Isosceles, okay, with base angle being equal. So now I'm wondering, it looks like I thought I misspelled isosceles triangle. So it looks like I actually spelled it correctly. I'm going to confirm that now. Isosceles. Okay. I think I actually misspelled it. Okay. So that's the spelling of isosceles. Yep. Okay. So I think I'm back in business. Okay. So did you get the reason I put down here? The sum of angles in a triangle being 180 degrees. That's what made me to say 180 minus 56. One of the angles. Now I'm dividing it by 2 because the base angles are equal. So just get the difference and then divide it by 2. So you're good with that, right?
Yes.
Okay, good. So PQR will be equal to 180 minus 56, which is what? 4. 7 minus 5 is 2. And 1 minus 0 is 1. 124 over 2, which is equal to 62. Okay, 62 degrees. Okay, so now we have found PQR, which is what? 62 degrees. And this side too is what? 62 degrees. The question now is, what is the total angle? And that's what I'm looking for, CQR. So I can now go ahead and say angle CQR will be equal to 56 plus 62. All right. And that will give me 6 plus 2 will give me 8. And 5 plus 6 is 11. And that's my answer. All right. Did you get that?
Yes.
Okay. Sorry, it took a bit long, but I just felt I should explain that a bit. Okay. Significant figures should be a walk in the park for you.
Yes.
All right. What else? This guy looks like probability kind of percentage. So can you do number 19?
Oh, yes, yes.
Okay. All right. Okay, moving on. How about number 17? Number 17 has 3 questions, so let's look at 3 of them. The first one is expansion. Can you handle that? Or okay, maybe we should just do 17.
Yeah.
Right?
Yes, yes.
Okay. All right. So to expand that guy, 3 into bracket 4 minus 2x. Okay. So remember, the relationship between the 3 and the bracket is multiplication. So we multiply everything inside there. 3 times 4 is 12. And 3 times minus 2 is minus 6. Don't forget the minus in front of the 2. That's minus 6x. That's the final answer. 12 minus 6x. Okay, moving on. It says we should solve this. Whenever they ask you to solve something, it means you should find the unknown. All right. So having said that, 3y over 4 equals 12. So if you remember the principle of anytime something is multiplying what you're looking for, simply divide both sides by that thing. Doesn't matter what it is. If it's a fraction, if it's a whole number, if it's a decimal number, divide both sides by that thing. So right now I'm looking for y, and somehow 3 over 4 is multiplying y. So I'm going to simply divide both sides by what? 3 over 4. Now, remember 3 over 4 is a fraction. So dividing both sides by 3 over 4 is as good as multiplying both sides by 4 over 3. Okay, don't forget that principle. So that means that therefore, y will be equal to 12 times 4 over 3. Okay? And that will be 3 in itself 1, 3 in 12, 4, and 4 times 4 is 16. And we're good to go. Finally, they said we should factorize 4p plus 6. And what I see that's common between 2 of them, because that's what it just means, bring out what's common between the common factors, the highest common factor that's there. So to factorize 4 and 6, we're simply going to bring out 2. Okay, that will leave me with 2p. That's how I'm going to get 4 back there. And then plus 3. Okay. Any questions so far? I think we're done with this. Any questions so far?
No.
Okay. All right. Okay. I believe now you understand what an isosceles triangle is. You can draw a triangle in a grid. Can you do that?
Yes. Wait,
Okay. But let me just give you a clue, right? Remember, isosceles just means that, I mean, the two, what do you call it? 2 sides are equal, okay? And then, of course, once you have that established, you know that the two base angles will also be equal. So if they said you should draw an isosceles triangle with an area of 12 cm squared, and each of these squares is 1 cm, right? Then let's see, to get 12 cm, it means that I'm going to gauge it in such a way that by the time I look at what I have, I should have 12 squares in it. Okay, 12 squares should be inside that triangle. Whatever I'm doing, 12 squares must be inside, and it must be symmetric so that I'll have the 2 sides equal. So for me to get 12 squares, let me see if I can. How many are here? 1, 2, 3, 4, 5, 6. Okay, so let me see if I do 6, right? Let me see if I do 6 with that, and then I start from here. 6. Okay. And I make sure that my line passes through this, Oh, I think I'm seeing that I may have, okay, let's see. So, okay, so this thing is like a thing of gauging. So just pretend what I'm drawing is a straight line, right? I'm passing through I'm halving each of these squares by passing through that diagonal. Just pretend that that's what I'm doing. Now, so far, let's see what I have. I have half plus half, that's 1. Half, let me do another half plus another half. So let's gauge it up to that. Half of this square plus half of this square, that's 2 altogether. Then let's now add the squares that come before the middle. Okay, the middle line. Okay, let me just do this for the middle line. I'll just make it dotted line. Okay. So whatever is on one side, by the time I double it, it should give me what is on the other side. Remember, I'm looking for 12 squares. That's what will be 12 cm squared. Okay, so I already have 2 now. Half of this plus half of this is 1. Half of this plus half of this, making 2 altogether. So let's add the remaining one that is whole, that are whole rather. 3, 4, 5, 6, 7, 8. Now, if I do the same thing on this other side, it's going to give me 16, but I need 12, not 16. So that means I have to back up. Let's see if I end here, whether it's going to give me 12. I had 16, so I need to take 4 out so that I can have 12. Okay, let's see what I have now. 1, 2. Oh, so the thing is, this is not equal. That's the issue now. Okay, so I have 1, 2, 3. So 1, 2 will be my what do you call it? Okay. Okay, I think I have an idea now how I'll get it. So this and this will make one complete square. This and let's see if I draw this on the other side, if it's going to be complete now. So this and this will make one complete one. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So now I need to make it complete to make it 12. Okay, so there's something else I'm looking at that can help us to achieve 12 cm squared. Now, a right angle triangle whose 2 angles are 45 degrees is also, what do you call it? It's also an isosceles triangle. The only thing is that it is kind of flipped. So that's another thing I can do to get my isosceles triangle. So this is what I want to, this is what I mean. Sorry, I only wanted to give you a clue, but I don't know if you have a way you could use to resolve it. But yeah, let's see if my clue would help. Okay, so I want to achieve a right angle triangle and the base angles are equal. So of course, I'm not going to measure the angle. I'm just going to take a bet on this grid giving me 12 squares. So here we go. 1, 2, 3, 4. Let's do this. 5, 6, 7. Okay, so 1, 2, 3, 4, 5, 6, 7. Now, if I do this, so this is what I want to now do. Okay, so let me include this one. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I have to add this one so that everything will be complete. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then let's see if I draw a line that will pass through this, through this, through this, through this, and through this. So let's see what we have is if it's up to 12. So 1, 2, 3, 4, 5, 6, 7. Now, careful now. This and this will give me 8. This and this will give me 9. That's 9.5. Okay. So we need 3 more to make it 12. All right. So maybe I should take my line one step higher. Let's do this. 1, 2, 3, 4, 5, 6. Okay, so let me erase this and see if it's going to give me 12 squares now. It must be exactly 12. If not, we're not doing 12 cm squared. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh my. Okay. So Noah, do you have an idea? How would you take on this question? I'm just curious. How would you take on this question? My efforts to get 12 cm squared seem to be falling short. How would you take on this question?
So if the area is 12, then half 12.
Yes, you should have, because each square is 1 cm by 1 cm. So if we're going to achieve 12 cm squared and an isosceles triangle with an area of 12 cm squared, then by the time we add up everything, it has to be exactly 12 cm. So I was just thinking of how, I know it's a ruler work, really. It's just a ruler work, but it's how that ruler work is going to play out. That's what I am thinking. So let me see if we do this. 1, 2, 3. Okay. So I have 1, 2, 3, 4, 5, 6. So I need 6 to make it up to 12. So 1, 2, 3, 4, 5, 6. If those squares are equal, then that will make it 6. Okay. Okay. No, I don't know. What do you think? An area of 12 cm squared. Oh, I just thought of something now. The formula for area of a triangle is half base times height.
Oh,
right?
it,
So that's yeah. I just got it. That's the best way to go about it. If we do this, we might spend almost the whole time trying to figure it out. So yeah, half base times height will sort it out, and you're good. So if you do have base times height, you're covered. And in this case now, for us to get 12, then that means that will come out from 24 divided by 2. So that means your base times height must give you 24. Is it possible for us to find two numbers that when we multiply them the same, they will give us 24? Is that possible? 8 times
Yes.
3 is 24. 6
Six
times
six
4 is 24. 6 times 6?
6 times 4.
6 times 4, okay. 6 times 4 is, oh, yeah. Okay. Sorry, they don't have to be the same. Yeah, I just remember, they don't have to be the same. So 6 times 4 is 24, right? So if the height is 6, so I just need 6 squares, 6 cm, and then the height is 4. So if I do this, 4, this is 1, this is 2, this is 3, and this is 4. So if the height is 4, right, and the, what do you call it, the base is 6, let's count 6. 1, 2, 3. 1, 2, 3. So if I do this, I think I should be in business. So this is what I'm going to do. My aim is to get to this point. So I'm going to do this, do this, do this, and do this. Let me see if is it complete now. 1, 2, 1, 2, 3, 4, 5, 6. Okay. Let me see if that's 1, 2, 3, 4, 5, 6. Let's see. Okay. Let's see. I think this should be complete. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Looks like we have slightly above 12. Okay, Noah, I think you'll be able to work out something. Just take a look at the mark scheme, so we don't spend too much time on this question. I'm not too sure why it's that bit of a problem, but yeah. Okay, let's move on. Here we have number 14. Is number 14 something you can handle? Okay, statistics. Maybe we should just do it. Let's just do it. Number 14, it says, here is the shoe size of each of 12 boys in a class. And it gives us all that. And guess what? They're all arranged in ascending order. So that's a good thing. They now told us to find the median. Remember, median is the middle guy. The guy in the middle, after arranging it according to what? Either ascending order or descending order. And in this case, it's ascending order. So since we have 12 boys, that means we're going to have two things in the middle. So let's count. 1, 2, 3, 4, 5, and 6. So these are the middle guys. So let me count the other one. 1, 2, 3, 4, 5, and 6. So the two middle guys are this guy and this guy. So you know what we're going to do, right? 7 plus 7, right, divided by 2. That's going to be 14 divided by 2, which is still 7. So the median is 7. Now remember, if we had an odd number of boys, let's say the boys in the class were 13 and not 12, then you would have had a clear number in the middle. You wouldn't need to do all this 7 plus 7 that we did here. You'd have just had a clear number in the middle. Pick that number, that is the median. Okay, but remember, the median can only be obtained after the distribution has been arranged in either ascending or descending order. But like in this case, we didn't need to arrange it anymore because it's already arranged, which is a good thing for us. So moving on, it says work out the range. And I told you range is the difference between the highest number and the lowest number, okay? So the highest number here is 9, I presume, and the lowest is 4. So 9 minus 4 is 5. Next, we have that it says for the shoe sizes of each of 12 girls in the same class, I guess, the median size is 6 and the range is 3. It now says we should compare the distribution of shoe sizes of the boys with the distribution of shoe sizes of the girls. Okay, so I know that the mark scheme may say something extra, but the thing is this: median is usually a measure of central tendency, which means that if you need one statistic that can represent the for the boys, then that means that the median is one of those kind of measurements. So it means that the boys have more likelihood to have bigger feet, right? Because theirs is clearly larger than the girl. So you have more boys that have um, um, bigger shoe sizes than girls. Now, there's something about range. Range is not a measure of central tendency. It's what they call a measure of I've forgotten now. Distribution. I've forgotten. But anyway, it's most likely the opposite of central tendency. So I can't really put my finger on the what do you call it? Um the interpretation for that for range. But if you understand the fact that range is the difference between the biggest and the smallest in each case, then it seems to me that the number, the variation for boys seems to be higher than that for girls, because for you to get 5, 9 minus 4 to give us 5, it means that and then for girls it's just 3, then it means that the difference, whatever would have given you 3, the difference between the biggest girl's shoe size and the smallest girl's shoe size is not that much. Okay, do you get where I'm coming from?
Yes.
Okay, so that equally tells us that, yeah, possibly the girl with the biggest shoe size is not too her size is not it's not too much, it's not too bigger than that of the one with the smallest as compared to that of the boys. So yeah. Yeah, I'm sure the mark scheme will have something more comprehensive than what I said, but yeah, it's relatively what I explained. Okay, so here we are moving on to the next one. Is there another question there? Oh yeah, there's another question. Okay, I believe you can handle this with your calculator, right?
Yes.
Okay, so I'm skipping it. This is bearing. Is this something you can handle too? And I think it's working with a scale. Okay, so is this something you can do on your own? Sorry, I
Yes.
didn't hear you.
You have to do it.
Okay, you can figure it out, right?
Yes.
Okay. All right. Okay, so we move on then. Okay, sorry, let me go. How about number 11? Sinita wants to make 35 picture frames. She needs 4 nails for each frame. Sinita has 3 boxes of nails, and there are 48 nails in each box. Has Sinita got enough nails to make all 35 frames? Show how you get your answer. So how will this play out? Let's see. Let's see the first thing that we have. 35 picture frames, 4 nails for each frame. So that means she needs a total of 35 times what? 4 nails, right? That's going to give me 4 times 3, 12. 4 times 5, 20 rather. 4 times 3, 12 plus 2. That's going to give me 14. That's 140 nails altogether. Okay? Okay. So that's the total she needs. But she has 3 boxes of nails, and there are 48 nails in each box. So what she has, this is what she needs. Okay? This is her need. This is what she has. Okay? She has 3 times 48 nails. Okay? So that's going to give us what? 3 times 8 is 24. 3 times 4 is 12 plus 2, 14. So she has 144 nails. So I guess she has enough, right?
Yes.
Okay. Moving on. Here is a list of 8 numbers. Kim picks a random one of these numbers. On the probability scale below, mark with a cross the probability that Kim picks a number 7. Now, there's no 7 in there, so obviously that's a 0. It's not a possibility. Next, it says on the probability scale below, mark with a cross X the probability that Kim picks a number greater than 5. So my number of required events is going to be how many numbers there are greater than 5? Clearly greater than 5. I have 1, 2, 3, and 4. And there are 8 numbers. So that's 4 over 8. So 4 over 8 is going to give me 1 over 2. So that's half. Okay. So probability that it is greater than 5 is equal to 4 over 8. And 4 over 8 is 1 over 2. 1 over 2. All right, next thing we have is that what's the probability? Find the probability that Kim picks an even number. Even number, probability of even. Let me just put it like that way. Probability of even, right? Even is equal to what? And how many even numbers do we have there? 1, 2. Okay, let me count it on the 1, 2, 3, 4, 5. So that's going to be 5/8. So that's the probability that it's going to be an even number. Okay. Are you good with that?
Yes.
Okay, excellent. Okay, I'm sure number 9 should be simple for you. Number of faces on a prism. I think this one is 1, 2, 3, 4, 5. There are 5, right? Okay. Number of edges should be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so do you agree with the fact that there are 5 faces on this guy?
Yes. Yes.
How about the number of edges?
9.
Okay, 9. Okay, yeah. Okay. Excuse me. It says here are the first 5 terms of a number sequence. Obviously, this looks like an arithmetic sequence. How do I know? Because between 3 and 8 is 5. Between 8 and 13 is 5 again. Between 13 and 18 is 5. And between 18 and 23 is 5. It says write down the next 2 terms of this sequence. So that's going to give me 28 and 28 plus 5 should be 33. Okay, that's it. Next, Jim says that 50 is a term of this sequence. Jim is wrong. Explain why. Well, it's quite simple, but for you to explain why doesn't now mean you should add all this till you get to 50. But then another, the easiest way would be to use the formula for, what do you call it? The formula for arithmetic sequences. So since we've established that it's an arithmetic sequence, right? It's fair enough for us to use this to show that 50 can never be a term in this sequence. Okay. So maybe there might be another way to go about this. So, but well, this is how I would have done mine. If I establish A, right? A is my first term. So that means the sequence for this guy, the formula for this guy will be A, which is 3. 3 plus n minus 1, your n minus 1 is the term, so you can leave it at that, n minus 1. Then my common difference is 5, okay? So for me to prove that 50 cannot be a term in this sequence, it means that we'll first have to assume, okay, if 50 is a term in this sequence, 50 should be, we should be able to say that 50 equals 3 plus what? N minus 1. And let's see if that's a possibility. Now, if n is a whole number, right? Then that means 50 is a possible term if n is a whole number. But if it's not, then it's not possible. So how do we find out? Just make n the subject of the formula. So first things first, let's take 3 to the other side. That's going to be 50 minus 3 equals n minus 1. Remember, the relationship between 5 and that bracket is multiplication. So we can't take 5 to the other side just yet. 50 minus 3 is 47. Okay, I can already see that things are not going to play out nicely. 47 equals n minus 1 times 5. So to take care of 5, I'll divide both sides by 5. And this is what I'm going to have, 47 over 5. So you can see clearly that, I mean, there's no likelihood that n will be a whole number because 47 over 5 itself is not even a whole number. 47 over 5 is what? Is 9 remainder 2, isn't it? That's 9 whole number 2 over 5. So there's no likelihood that this guy is going to come out a whole number because look at it. The next thing you're going to have to do is to add 1 to both sides. So therefore, n cannot be a whole number because n is equal to, by the time you take 1 to the other side, it's going to become plus 1, which will make that 9 to become 10. 10 whole number 2 over 5. So you can see clearly that n is not a whole number. So that's the reason why 50 cannot be a term in this sequence. Well, someone else could have said, okay, for 50 to be a term, what should they do? They will keep on adding 5. But I'm not sure that's a good way to go because what if the number was bigger than 50? You won't take your whole time, keep on increasing it like that. So yeah, this is a good way to prove it. Just prove it and end it. Okay. So can I move on now?
Yes.
Okay. You can handle this, right?
I don't understand number 6.
Okay, number 7, right?
No, number 6.
Number 6. Okay. Number 6 says draw on the grid, draw a quadrilateral with no lines of symmetry and a rotational symmetry of order 2. A quadrilateral. So a quadrilateral is a shape that has 4 sides. No line of symmetry. No lines of symmetry. So that means it's not regular. Rotational symmetry, rotational symmetry. Let me see. Rotational symmetry, rotational symmetry. Okay. Just give me a minute. Okay. 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 I'm trying to establish. I think the only thing that is a bit confusing in that question is that rotational symmetry. The number of times a shape appears the same during a full rotation is called the order of rotational symmetry. For example, a square has a rotational symmetry of order of 4 because it looks the same 4 times during a full rotation. Okay. Okay. Okay, so for this one to have a rotational order of 2, they are saying that it can only look the same 2 times in that order. Okay. A quadrilateral with rotational symmetry of order 2. No lines of symmetry at all. Okay. So what I'm seeing is that, okay. Rotational symmetry of order 2. Okay, let me see how that would look. Okay. A quadrilateral with no lines of symmetry at all, and a rotational symmetry of order 2. Okay. Okay. So this what I'm presuming should be the how it will look. For it to have rotational symmetry of order 2, it means if it's turned 2 times, if it's rotated 2 times, it will only look the same after 2 times of rotation. Okay, so let me see. I would most likely join this to this for it to be a quadrilateral with no lines of symmetry and rotational symmetry of order 2. Okay, this is what I'm presuming. I tried my best to make this side and this side to be at 90 degrees, right? Because of this other condition, rotational symmetry of order 2. No lines of symmetry means that if I draw a line through it from here like this, I shouldn't be able to draw a line that would divide it into 2 equal parts at any point in time. If I start from here too, I shouldn't be able to draw a line that divides it into 2 equal parts. Also, of course, I mean, these other sides too should not happen. No line of symmetry across it at all. So, yeah, this is what I think it should be. But you might want to look at the mark scheme if it has something different there. But the whole idea of rotational symmetry is that if you turn it round twice, because this one has an order of 2, as opposed to a square that has a rotational symmetry of order 4. If you turn it round twice, it should look the same only for those twice that you've turned it round. The ones that go after that, it will not be the same. Okay, so does it make sense in any way?
Yes.
A little, okay. Okay. Okay, so I think we've come to these guys that are kind of a giveaway. Okay, so which one should we do first? Let's look at number 1. 35% as a fraction. That's 35 over 100. They didn't say in its lowest terms, but I can bet you that it would be good for you to take it down to its lowest terms, right? 5 in here is 7. 5 in here is 20. So we have 7 over 20. That's 35% as a fraction. Work out 1 over 4 of 28. That is nothing but 1 over 4 times 28 over 1. And that's 4 in here. It's 1.28 is 7. So again, the answer comes out as 7. Write down 2 factors of 12. Easy. 2 and 3. Of course, we know the others, 4, 6, and 12 itself. Of course, even 1 is a factor of 12. Simplify 2n times 3, nothing but 6n. Find the square root of 1.69. Okay, so now in finding the square root of this guy, right, we'll remember that 169, square root of 169 is what? 13, isn't it? Noah, are you with me?
Yeah.
Okay, so square root of 169 is 13. Therefore, for you to get 1.69, it simply means that you have to put, okay, so there are 2 things we can do. This, in fact, I think this is how I would do it. If I were to do it, to make it straightforward, 1.69, right?
Yes.
Square root of 1.69 is the same thing as square root of 169 times, oh, sorry, 169 over 100. Sorry, not times. Is divided by 100. Okay, so that would further be, that would be equal to square root of 169 over square root of 100 over square root of 100. And we already know that square root of 100 is what? 10. And square root of 169 is 13. So 13 divided by 10 is 1.3. So I guess you can do this with a calculator. I knew you can do it with a calculator, but if you were in a situation where you didn't have a calculator, this is how best you could go about it. But now that they're saying show your working, I don't know. Write down all the stages in your working. I think this is good for you to know anyway. Okay. So let me save this and I'll send it to you.
Thank you.
Save as annotated with answers. Okay. 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 So the exam is tomorrow, right?
Yes.
Okay. Okay. I wish you the best. I know that you will ace it. So just Just be careful with the questions. I'm sure you'll be able to do a good job at it.
Thank you.
All right. So the next paper should be chemistry paper 2, right?
Yes.
Okay. Would you like us to use a past question for it?
Yes, please.
Okay. Okay. So maybe by tomorrow you'll be able to come up with one, right?
Yes, yes.
Okay. Okay. All right. Do have a good night, guys.
Thank you, you too.